Okay, this chapter from this book can be concluded with this podcast. I will add material from other books and some thoughts on impacts of warming on cyclones, which is a big topic these days, and GFDL maintains a very good statement on it, which we can go through. To look at some of the eye wall transitions, remember that eye wall will be eroded. The rain shield in a storm undergoing extratropical transition will expand and shift to the left of the track. We know that asymmetry comes in, and dry slot will wrap cyclonically around the storm from the poleward side. So let's look at some examples. The book actually asks you to look at them and identify the ones that did the extratropical transition, but I'll just show the answers. So tropical cyclones that have undergone extratropical transition are outlined in gold. So you can apply those criteria to look at these unnamed tropical cyclone of 1991, superstorm of 1993 which didn't transition, Michael which did. You can clearly see the asymmetry here, and the warm and cold fronts. Maybe this is the warm and cold front that tilts northwestward with the cyclonic circulation. Noel didn't. Perfect Storm of 1991, which is a great book and a movie, didn't actually transition to a extratropical storm. This is an extratropical low, Floyd of 1999, and the last one that did transition was Gloria in 1998. Okay, so you can look at these characteristics and see if you can identify them. To close out, let's look at societal and environmental impacts of cyclones. Of course, there are direct impacts because of the winds and the rains. Lots of flooding and wind damage can happen, but often the indirect effects kick in, where infrastructure is damaged, power is knocked out, hospitals, trains, tracks, airports may be knocked out, and so on and so forth. This is a good example where now we have to think about globally connected economy. So the Philippines got hit by Typhoon Haiyan, one of the first ones which made a lot of news about whether it got much stronger because of global warming, and if it did, then the additional damage caused by it, could it be attributed to the rich countries which did the major contribution to global warming, and whether damages could be paid to Philippines for the additional loss of life and property and so on. But looking at the direct impact, 6% of all US production relies on supplies from the Philippines, and all these other countries were affected by direct supplies. And in terms of secondary impact, 21% of the US production could suffer indirectly from supply chain problems. That was in 2011, but now with every major cyclone that affects one supplier somewhere, global supply chains are affected. So in terms of climate adaptation, now we probably have to think of it as being all together. So you cannot, just like COVID going around, for example, G7 countries are going to provide 1 billion vaccines to the developing world, because unless everybody is vaccinated, this thing could keep coming back as multiple waves. We are already in third, fourth, fifth wave in many places, right? But what is remarkable about cyclones, typhoons, hurricanes is that the storm surge and wind-driven waves indicate that the available documentation that whenever there was a large loss of life from tropical cyclones, the predominant cause of death was drowning, not wind or wind-blown objects or structural failures. This is from Rappaport and Fernandez Partegas from 1995, and this still seems to be true. And here is a conceptual model of storm surge and photograph of a boat here carried inland by storm surge. So this is these are serious monsters. This is showing a mean sea level, 5.2 meter storm tide being brought in with addition of 0.6 normal high tide. So you can see the storm surge of 4.6 meters. And of course, with warming, as sea level rises, we have to keep watching out for this additional storm surge because of the sea level rise, right? So this is getting now quite complicated in addition to the rapid intensification, cyclones moving slowly which dump more rain, and them stalling near the coast because of ocean warming can really wreak havoc. And Houston, for example, got something like 36 inches of rain from Hurricane Harvey, I think, a few years ago. So these things are now becoming more and more common, in addition to the extreme events already happening. Bangladesh has had some real misery with cyclones. We will just run through some major cyclones here from 12th November 1970. The cyclone formed over Central Bay of Bengal on 8th November. As it moved north, it intensified, reaching its peak 10 minutes sustained wind speeds of 50 meter per second or 185 kilometer per hour. It's category 3 on Saffir-Simpson scale. Saffir was the one who put the wind scale on it, and Simpson added the storm surge inundation, which has since of course had to be modified. With minimal central pressure of 966 hectopascal. This cyclone killed, I think, over 167,000 people. There were no hazard mitigation in place, and Bangladesh is a low-lying region with lots of deltas and islands, and evacuating islands is obviously not possible, so people have to hunker down in place and hope for the best. So even when there is good forecast, often we used to end up with lots of deaths, which has changed fortunately by now. So this is Tropical Cyclone O2B from UTC 1900, 29th April 1991. Flooding and landslides, you can find enormous amount of photographic evidences of these things online. I'm just using whatever is in the book. So the flooding and landslides often depend on the configurations of the island, the land use, deforestation, and what happened before the storm arrived. Maybe, for example, here tropical storms Isidore and Lily together hammered flooding in Magadi, South Jamaica on 30th. So if ground is saturated by one cyclone, which may not have been severe, then even if the second cyclone is not so severe, flooding can happen because there is just no way for the water to go or soak in. Okay, so these things are quite common, and this is interactions of Agnes and the mid-latitude trough here in which year was it? Anyway, just keep looking at the figures. Schematic of the mid-tropospheric streamlines associated with the possible tropical storm flooding. So trough is when the jet stream dips south, as we know. So there is region A and B, and these are the regions where maximum rainfall happened because of these interactions of Agnes and the mid-latitude trough. This is these flooding can also depend on how the river is oriented and whether it's a narrow river or a wide river with lots of floodplain available for it to expand, and so on. Susquehanna River is a narrow river coming through cities down from Pennsylvania into the Chesapeake Bay. So this is Susquehanna River flooding from the remnants of Hurricane Agnes, Wilkes-Barre, Pennsylvania, June 1972. This is, you can see the damage done with blocks and blocks of house basically under water. Okay, so specific regional specificities of the storm and the land and where it's going matter a lot. One of the worst, most damaging hurricanes in the Western Hemisphere has been Hurricane Mitch from 1998. So Hurricane Mitch at 2028 UTC on 26th October 1998 at peak intensity, central pressure of 905 hectopascals, maximum winds of 80 meter per second. That's well over 200 kilometers per hour, maybe 250. Satellite derived rain rate 26 to 30th October. You can see there's massive amounts of rain rates of up to 27 millimeters per hour. You can imagine just how much rain fell in these parts of Central America. Okay, so Nicaragua, Honduras, Belize, and Mexico getting hammered by Mitch. Strong winds and tornadoes. We talked before about how tornadoes are spun off by some cyclones as they crash on land, interact with topography, and so on. Here's an example of a plank driven through by a trunk by a tropical cyclone winds. People may use these to board up the house's windows to protect their property, but they can become flying objects when the pressure, for example, drops to very low levels by the storm outside and the house is sealed. Then you have explosions and the flying objects like these planks. Lightning, of course, is a major concern. Here is an image of lightning flashes and radar reflectivity from Hurricane Charlie in 2004. Lightning flashes and radar reflectivity, maximum flashes are occurring in rain bands to the northeast of the eye here, which is over central Florida. And here is the eye that you can see, and this band way out there is having a massive lightning storm, which obviously can kill lots of people. Cyclones are not done. Even when they make landfall, they often can go off back on sea and re-intensify and transition to extratropical cyclones. So here is the impacts can be large as well, as we saw some landfall in Alaska, for example. There are landfalls that happen on Canadian waters, on European places from the hurricanes that come off. Indian Ocean in the southern part, there are some examples of extratropical transitions, but in the northern Indian Ocean, obviously that's not a serious concern because the land is closed off at lower latitudes. So here is a stationary fetch length and the dynamic fetch length of an extratropical transition. Conceptual model of a tropical cyclone with a straight storm path and fetch on the right flank outlined with dotted white line here. Okay. Waves within the dotted line experience a longer period of wind forcing. You can see here. The distance over which they grow is called effective or dynamic fetch, which is this purple line here. Okay, so that's the path, that's the secondary fetch, and this is the dynamic fetch length, which we talked about before. So the cyclone is not done. It can create havoc even as it transitions. Hazard mitigation now rely a lot on accurate predictions, warnings, alerts, evacuation orders, shutting down of businesses, creating sheltering places in schools, churches, stadiums, and so on. And these kind of signals or road signs put up. Of course, you can see the bridge here is completely covered in water. People don't know how deep it is, and they try to drive through confidently and get into trouble. So this is U.S. National Weather Service warning against entering flooded areas. In countries like Bangladesh, number of deaths have been reduced dramatically from the times of the 70s and 80s when 100,000 people, order 100,000 people used to die. Now it is down to just a few thousand, still very high, but it's a great improvement. In India, states have become very good at following forecasts and making plans to evacuate people and protect them. There is evidence that giving a little bit of education to women can reduce the family's vulnerability to these natural hydroclimatic hazards, because they are much better at listening to the warnings and taking decisions and protecting themselves and the family and so on. Infrastructure itself is now being is considering cyclone threats, risks of sea level rise, inundation, storm surge, and so on. City like Mumbai learned its lessons from the 2005 flooding, so now it handles floods much better. It's already flooded in the monsoon this season, as I'm recording this on June 10th or 11th, 12th I think. So awareness is very high. Discussion of global warming impacts on cyclones is getting attention, but places like Houston, which got hammered and lost a lot of housing, may rebuild, because one bad experience is forgotten after a few years, but if they get hit again and again, then maybe they make changes in plans. Insurance companies are making changes in the way they provide flood insurance for people who live in flood-prone areas from cyclones, like Florida, for example, and the eastern seaboard in general, and so on. So hazard mitigation is a big part of the dealing with these unavoidable disasters. Okay, so they are called managing the unavoidable and avoiding the unmanageable, and so on. Okay.